Hi everybody, my name is Anibal Azevedo and this is the third class of the third track about how we can apply artificial intelligence tools to help a container port supply chain operations. So now we're gonna start with the code from previously class. If you didn't see, let's start some card somewhere here. And now we're gonna use the previously code that to explain the previously class. And now I gonna let's start code here. Remember that in the description of this video we have all code for free, so we can copy or you can just save a copy on your drive and can modify the code. Okay. So now we have this. Oh, I forgot that. Terrible. Oh, we already have this. Okay, no problem. No, we don't have. If we don't have the previously code, can have this. Save a copy. More interesting. Save a copy. Let's change this name. Or more interesting than copy everything. Okay. So I'm saving a copy on my drive of this. It's a kind of notebook and it's a kind of Google Drive document that you can save any name different. So just take care about here. You should preserve this dot ipy and notebook ipy notebook name, because this extension is important to identify that this document we have some Python code. Okay, so we have to reload this. I could click here to create the definition of a container ship class. Also, I can click all cells here, and this will okay. So it's loaded the definition. Also test performing a test if the code is operating. Okay, it's all right. Now let's check here. You can click here. They will load all cells that are hidden. And okay. So after doing this, we can refine this code that we commented and created in the last class. And what we should improve here, what is not right here. For every port, we should explicitly write instead of using a for command or a loop. So what we should do here, we start here, and after define the initial container ship cargo and the variable cs1, we should do this. N is the total number of ports. Okay, so we can use shape 0. So it's the dimension of lines, how many lines the matrix T has, and print this variable value is number of ports equal to n. Okay, so I will just erase this. Erase is not a very good option. I will keep this because it's interesting to know what's the difference between the previously code and the code that we are making now. So what's important here, every time a ship arrives at a certain port, the ship should perform first unloading rule, okay, unloading operations. So how we can represent this? We can represent this by a for p in range. So p is the letter that the variable that it identifies the container, the port container ship port that we are. So now we have this range 1 to n. Okay, so let's see what happens if I use this for. will use print p equals to p. Okay, so let's see if this is working correctly. So okay, so I have here port number of ports 3. So we will go to the port 1 and then to the port 2, right? Okay. So whatever. As you can see here, the transportation matrix has this line and this and this. The range. If you want to go also to the last port, you should do this. N plus 1. Now it's okay. So then the p variable will be until the last port. Okay, now. So I can change this to port p, and so if I in the port p, I the first port, so I should use this auxiliary list, and if p is greater than 1, this means that we are not in the first port, because in the first port we suppose that we don't need to apply any operations of unloading operations, okay? Because we are already in this port. So we just perform unloading operations for next ports, port 2, port 3, and so on. So we're gonna use always this unloading rule. Yes, 1. This is the variable that contains the container ship that represents the container ship and has also the containers. And finally, print cargo unloaded. So if we are in the port 2 3, first we should perform unloading operations, and then after do this, we can uh, catch all containers that we should catch all containers. This is it. Catch all containers from this vec. We can use just this without using this equation, because this is a reference to the list. So if you modify inside the combine function this list, the content of this list, they will return, just apply the return, and we will return, this function will return the modified list, okay? Automatically by reference, by using the reference to this list. So cargo to be loaded equals to, so this combine I already explained in previously videos, right? And I already defined it also in the previously videos. Okay, so now we're gonna also see how many movements we should perform. Uh, in fact, we should also have a variable that counts each time we perform unloading operation and load operation. We should accumulate this. It will be very interesting to have the total number of movements that we have performing, so we can have a total. And each time we have this and mov number of movements that we perform doing unloading operations, we can do this. And also, after perform unloading operation, we can do this. And total will be total. plus number of movements. Okay, so finally, okay, why I don't know why. Okay, after doing this, we can have total number, and finally after this, we can see the the ship after perform a loading operation. That's interesting to see after perform loading, unloading and loading operations, how this ship will move out from the actual port. And finally, after finishing this for this loop, how many contain movements we have performed uh, for to do the ship's operation through the simulation. As you can see here, we don't need to put, okay, we are in port 1 and port 2 and perform repeatedly every operations. So this loop has the advantage that if you have 10 ports of 5 ports, you don't have to concern about the number of ports. They will work, okay? So let's see what's happened here. Let's play this and see what happens. Uh, okay, just waiting. I don't know why today is taking this time. Okay, so finally we have here initial ship on port 1. This is the initial configuration of the ship. After do, okay, we start on port 1 and loaded some more cargo. Okay, so we have this cargo that is not, or this stack is not ordered, and this another two stacks will have trouble. So I have to unload some blocking containers, and we have also to reload them. So cargo to be reloaded. These two first, and these three should be loaded the first time in port two. Okay. So after doing unloading and unloading operations, the container ship will move out from port two with this container ship arrangement, and on port three we have three more containers, which destination is port four, and I also have to reload uh, two containers, which destination is port four, because we have to move these containers. Okay, so I have to on port three we have unloaded uh, these two containers, which destination is port four, and also this because we have to move this container, which destination is port four, because this container is a blocking container. So we have to reload all them, and when we reload all them, we get this container ship arrangement, leaving from the port free, and finally we finish our simulation with a total number of movements of 40 movements. Okay, so we can also perform, each time I perform some loading or unloading operation, I can print the number of movements that I made. It's also an interesting feature to have a detailed report about what's happening in the ship every time we perform some operation. Okay, so we started to build the simulator. We have already have a very simple simulator, and with a little code, we can build a very interesting simulator. But we have a big trouble here because the unloading and loading rules, they are fixed. Okay. So I want to use another. I should write here. I want to use this rule, or this one, or this one. So how we can code in a manner that we can easily change this the rule unloading or loading rule that I will apply, right? So the thing here is to understand how we can code this in an efficient way. So I'm gonna show in the next video a very interesting manner that you can code this very efficiently. How we can code a combination of rules in terms of numbers. That's gonna be very, very, very interesting. I've never seen something like that in the literature, and I have reviewed many papers. I have published some papers, and no one have used the code that I will show in the next video. So don't forget to see the next video, okay? So I hope you find this video interesting and useful, and see you in the next video. Bye.